Hey there, Geometry Group. We are going to do a little bit of review of something called algebraic proofs. We actually did this way back in the day in our Chapter 3 set of lessons, but we need to review it because what we're going to talk about in our next chapter deals with proofs. So we need to get our brain thinking about proofs, and what better way to come back from a nice 2-week-long break than to review and not start something brand new. So here we go. I haven't decided what section title I'm going to give this, like 11.2 or something like that, so I'll do that when I create our assignment, but this is just going to be titled Algebraic Proofs. So here we go. We're going to start off with an equation. We're going to solve it, and in solving it, we are going to show every single one of our steps and provide a reason. So here comes our task. I'm going to tell you that we have the following equation. We're going to have 2x minus 6 plus 3x equals 14. And I'm going to set this up looking just like a proof. I'm not sure if I have enough lines. I might have too many. Just kind of wing it. And this very first step is going to be are given. We're going to start off with a set of information, and our task is to follow through all of the steps, showing our work and giving reasons, and prove something that we need to be told. So in looking at this equation, I'm going to tell you that our task is to prove that x equals 4. If I did it right, real quick in my head, we should be proving x equals 4. So by the time we're done, this needs to be our very last statement over here, and we'll have a reason that we get there. So when I look at this equation, the first thing my brain says to do is to combine the 2x and the 3x for a total of 5x. And then we'll have the minus 6 and the equals 14. But we have to give a reason for it. Now, I know that 2 plus 3 is 5. I totally get that. But combining like terms is not technically a mathematical property. And you might be thinking, mathematical property? What is she talking about? Well, way back in the day, in Chapter 3, we had a series of properties. We had the property of addition, so the addition property of equality. We had subtraction. We had multiplication, we had division, we had distribution, we had a ton. And in fact, they're actually in your book on page 26. These are our algebraic properties, but not a single one of them is combining like terms. So let's look again at what we did. We said 2 and 3 x's made a total of 5x. Well, we can't call that addition because it didn't happen on both sides of the equation. It's not subtraction. Multiplication, division, nope. Now, wait a minute. What about substitution? 2x and 3x, we rewrote that. We changed the name of that to be 5x. Let's call this substitution. Now, you are welcome to do appropriate abbreviations. You can't abbreviate this as sub because that could mean subtract. But if you did substa with the S and the T, I'd be okay and understand that that is substitution. So let's continue on with this. Now I'm giving a blank space in between each one of the steps just because it's a little bit easier to see in the video. You don't have to. You can just link them all together and not skip lines. So I think my next step here, kind of feel like that would be to add 6 to both sides. So we'll get 5x equals 20. Now we have to write down what we just did. We added something to both sides of the equation. So that would be the addition property of equality. We're going to abbreviate it as addition, and you're probably going to abbreviate it as add. The next step, I'm kind of thinking we need to divide both sides by 5. And we will get x equals 4. Hey, we just proved what we wanted. So that reason that we got x equals 4, we divided. That is the division property of equality. That is an algebraic proof. Not too bad. The one thing that kind of trips us up right here is this substitution piece. When we do that combining like terms, we're changing 2x and 3x to become 5x. That's more of a substitution than an addition piece because it's that combining like terms concept. Now, don't think that we're done yet. So this was example number 1. Here comes example number 2. Debating which one I want to do. Let's go with this guy. We're going to start off with setting up our little proof columns. Now technically over here we are going to have our statement. I didn't title that on the first example. And then our reason on the right. And so down here I'm going to put down our task. Move that guy up just a little bit. So we're going to have negative 14 equals negative 4x plus 2 times 3 plus x. And that's our initial starting piece. So this will be our given. And our task is to prove, now hold on, let me just go find the answer real quick. I'm stealing this out of a worksheet and I'm always debating what problem should we do first and then second. If I wrote it down right, we should prove that x equals 10. Now you're wondering, how on earth are we going to get a 10 out of that? Well, let's go find out. So we're going to start off with our given. We need to take it exactly as written. And that's step number 1. And our reason, because we were told to. That is our given. Let me zoom in just a little bit for you. So my brain is looking at this equation and I'm thinking, I don't want those parentheses. I'm thinking we need to distribute through. So step number 2, we're not going to do a lot, but we are going to distribute through our parentheses. So what would be our reason? Well, our reason is distribution. Anytime we multiply through a set of parentheses, that's going to be distribution. Now you might say, why can't I write down multiplication? Because we didn't multiply on both sides of the equal sign. It's got to be on both sides if we're going to call it multiplication. Now I'm thinking here that my next step, I'm going to take that 4x and that 2x and I'm going to combine them. Well, that'll give me a negative 2x plus 6. And I know you're thinking, you kind of added, you kind of subtracted, but because it happened on one side of the equal sign, we're going to call this substitution. We are substituting the negative 4x and the 2x for a negative 2x. All right, let's get down to the next step. So now I'm thinking, I want to subtract off my 6 because I want to get my x by itself. That's going to give me negative 20 equals negative 2x. And my reason for that is subtraction, because we subtracted across both sides of the equal sign. And now, oh, we're so close. We're going to divide away our 2, and we'll get 10 equals x. And that would be division, because it happened on both sides of the equal sign. Now here's kind of a tricky last step. Because you're looking at this saying, okay, 10 is x. I just proved x is 10. We didn't prove x is 10. We proved 10 is x. And I know what you're thinking. You're thinking it's the same stinking thing, lady. I know, algebraically it is, but geometrically it's not. We have to make it look exactly like this, and the x has to be on the left-hand side to do that. So this is going to be a sneaky little 6th step. I'm going to flip this equation. If 10 equals x, then x equals 10. And the reason for this, and this goes right back to page 26. So we've got these properties. I know you're comfortable with addition and subtraction and multiplication and division. You're also really comfortable with distribution. It's these 4 down here that tend to trip people up. We tend to forget about it. Now, substitution is trading something out. Like, I don't want salad, I want French fries. You're trading something of equal value, something with a different name. Transitive. Oh, I just wrote my book. Transitive is where you start flip-flopping order of things, but symmetric. That's what we're really looking at here. If I'm going to switch the opposite sides of that equation and literally flip my equation over, that is the symmetric property. Boom, done. So be really careful. When you think you're done, make sure it identically matches what you're trying to prove and that you don't have a sneaky next step. I think I want to do one more. So let's see. For this guy, I'm going to do one with a little bit of fraction action happening. I did not mean to make that rhyme. I'm sorry. I don't like it when I do those things. So let's do this. We're going to have our given statement of 1/3 x minus 1/2 equals 1/6. Now keep in mind, it doesn't always have to be an x, but that's just how math teachers always think. So just go with it if it's a different variable. So on this guy, I'm cheating, I'm looking at my answer key. I believe what we're going to do is we're going to prove that x equals 2. Hopefully I wrote it down right. Let's find out. So we're going to start off with our statement and our reason. Statement number 1, we're going to have 1/3 x minus 1/2 equals 1/6. And that is our given. And eventually we want to prove that x equals 2. So on this, I really don't want to deal with fractions. I really want to make these fractions go away. So my very first step, I'm going to get rid of them. I'm going to recognize that every single number can be written as a fraction. In fact, we've got 3 of them right here. And I'm going to look at a common denominator. I think the best common denominator here is going to be 6. If I multiply every single one of those fractions by 6, I'm going to make them go away. So check this out. We're going to do 6 times 1/3 x minus 6 times 1/2 equals 6 times 1/6. I'm going to grab a highlighter so that you guys can see that we multiplied every single term by 6, by that common denominator. Well, here's my reason. This is multiplication. Now I've actually probably skipped a step where I should have multiplied a 6 just on both sides and had a set of parentheses. Bad math teacher, it happens from time to time. But we're getting the right idea. We multiplied both sides of the equal sign by 6. That's a multiplication property of equality. Okay, well here comes our next step. 3 goes into 6 twice, 2 goes into 6 3 times, and 6 goes into 6 once. And we just cleared out our fractions. But the step on this is not going to be multiplication or division, because that was previous. The step on this is going to be substitution. I replaced 6 times 1/3 with the number 2. I replaced 6 times 1/2 with the number 3. And I replaced 6 times 1/6 with the number 1. Now we're down to an equation that I'm okay solving. Let's add our 4 over. We will have step number 4, 2x equals, why did I say add the 4 over? Let's add the 3 over and we'll get 4. My brain was thinking the next step. That is addition, because we added something to both sides of the equation. Last step, we're going to divide by 2. We're going to get x equals 2, and that is division. So I'm hoping that little review of 3 equations written as proofs looks familiar. Again, this is on page 26. So we've got that addition, subtraction, multiplication, division, and distribution. You guys are really good at that. It's these bottom 4 that get us tripped up. Reflexive is saying something is equal to itself. 3 is equal to 3. And you're thinking, that's not very profound. What am I supposed to do with that? Not much. Symmetric is when we literally flip an equation over. Transitive is when we start like sliding puzzle pieces together. And substitution is when we trade things out. Really, that symmetric property and that substitution property, those are mighty handy for us. So I'm hopeful that that video helps us understand how to work through algebraic equations as proofs with steps. Yes, you have to do both. Alrighty, as always, let me know if I can help.